Okay, hello everyone. I'm Anurag Srivastav. I'm working as a technical director with Telesis Software. It's a US-based company with a development center and support center in India. I have around 25 years of experience in the industry, with almost all with the telecom equipment providers, and that's where I have interacted with telecom operators, those who provide the telephony services, mobile telephones. Today, I'll be talking about big data and advanced analytics, which will lead into AI with specific interest in 5G and beyond. So uh, I'll be taking you through this 5G. What exactly is 5G? What are the benefits that it provides? And then how analytics can be used, how data can be collected, and why is it big data, and what analysis can be done, and what kind of insights can come out of it. And then those insights further can be used to develop AI and a better set of applications for getting more perspectives from the same data. What is the 5G potential? Actually, 2.5G, 3G, 4G, they were basically passive content-driven dumb pipes. It led to rise of over-the-top service providers like Google, like Amazon, like Netflix, and so on, WhatsApp. And the focus in these generations was more on speed and capacity. The problems that telecom operators are facing as of today are falling or flat ARPU. Basically, average revenue per user is falling. It has come to a very low level. That means they are not getting same amount of money which they used to get earlier. There are technical limitations for providing the quality of service. There are regulatory issues like net neutrality and privacy issues, and there is a pressure of upgradation on the telecom operators. What does 5G bring in? 5G brings in, it is active instead of passive, and it becomes a smart digital enabler for the telecom operator as well as for the whole business as such. Why? It can provide differential pricing. It is intelligent network totally. It can help in developing newer business models, and there is a complete differentiation in terms of connectivity, service, content, and application. This all comes down to one thing, that you can control the specific aspects of the service that is being provided to you, and thus you can control the costs and provide intelligent routing of the system of the services. So what 5G brings, actually, in very common terms for everybody to understand, it brings higher speeds, which is very obvious with each G, 2G to 3G to 4G and 5G, the speeds are increasing. More bandwidth, that is more amount of data can flow. Lower latencies, and here, by the way, when I say lower latencies, I mean to say lower as well as many a times guaranteed latencies as well, because there are applications like the self-driven cars and all. You will require very low latency, and that too guaranteed at every point of time. So guaranteed and lower latencies, and it also brings convergence of fixed and wireless systems. So basically, it may be your broadband coming to your home, and your mobile services or your IoT, everything gets converged. And finally, it brings content closer to the user. What does it mean actually? In terms of content coming to the closer to the user, if we look at the traditional, on this top side, this green arrow tells you that the services are actually located on the cloud, and the content is served from the cloud. So basically, it has to travel through the core network, the access network, core network, external network, and to the cloud, and then back. Whereas with 5G, the content actually comes closer, and in fact it is on the edge. So it is mobile edge cloud which provides the services, and thus the round trip delay actually reduces a lot and latencies fall. This is just one example where cloud could give a latency, total round trip latency of, let's say, 80 to 100 milliseconds, whereas edge computing can actually reduce it to 2 to 10 milliseconds. This latency is very, very important in applications where you are doing real-time surgery, or you're driving an automated car. Literally, you take a few milliseconds to brake the vehicle, you might actually hit and collide. So that's where latencies would be really, really important. And so these are the 5G advantages. What does it bring actually in terms of, in very generic terms, people talk about 5G and say, what does it bring? So from 4G to progressive launch of 5G, where 4G and 5G both exist together, to 5G networks. So initially, the thing that will come up is EMBB, that is enhanced mobile broadband, which is actually talking about higher speeds, higher throughputs, which can be used for augmented reality and virtual reality, or ultra HD and 360-degree videos, because these will have higher data throughputs, more data requirement, more throughput requirements, more bandwidth requirement. So this is the first thing that will come up with 5G. Then the massive machine type communications, or MMTCs, which is basically the foundation for IoT, which leads to smart cities, smart logistics, smart metering, etc. Why this is different from, why this is very important? Because basically these IoT devices will be sending out bursts of data, or sometimes, and they will be silent for a longer period of time, but they have to be connected at all the times. So within a square kilometer where you used to have maybe 10,000 handsets, now it will come down to millions of devices, and thus the connectivity has to upgrade itself to get to this. And this is what 5G brings in. And the last thing, when we can get to complete 5G networks, we will have URLLC, that is ultra reliable low latency communications, which will be used for autonomous vehicles, smart grid, and factory automation, where the decisions have to be split-second decisions, as we call them. There are some misconceptions, and the misconceptions were that in 2020, all these three things will be available, that is EMBB, MMTC, and URLLC. But actually, the evolution is happening something like this. First, fixed and mobile access will come together. And the first and foremost thing which is visible is enhanced mobile broadband. And then massive machine-to-machine connectivity and ultra-low latency is the third. And the verticals are going to evolve around this. So basically, the 5G will continue to mature in this manner. Everything is not going to be available at the same time. That is why I normally tell a lot of people that autonomous cars or self-driven cars are yet to come. It'll take some time. You will not be okay to sit in a car which is driving itself on roads as of today. Maybe in the labs, it's perfectly possible. So, okay, 5G brought in all these things, but what actually happens with this? We can collect the data, and that is flowing through the telecom network, and we can actually analyze that data, and we can give a lot of insights. But there are really big challenges, because as the data throughput grows, the data collection strategies have to change. There are bigger challenges that come into picture. First of all, from the previous generations, there is a big paradigm shift where we had only voice calls or a circuit switch domain. There we were talking about calls which will be infrequent, even if somebody is calling a lot, but then there will be most of the times when the phone will be simply connected to the network and not doing anything. Whereas in packet domain, what has come up is basically the content. You are always on, your data is always through. In fact, when there is a WhatsApp message or a line message or a WeChat message, or there is a notification for some app, that's always on. So the connectivity is always on, and that is why what matters is the content itself, and time. Time only is insufficient to measure. So the latency and many more factors come into picture. That's the paradigm shift that comes here. If we are trying to look at the extracting the data, then there are three important factors: the accuracy, granularity, and flexibility. And this becomes challenge because as the amount of data grows, sometimes you may not be accurate, you may not be capturing each and every packet and and you won't be able to see that. So you lose accuracy as well as granularity, plus flexibility, because the systems are growing, new apps are coming into picture. So basically the data extraction systems should have, or a network probe as we call it in generic language, should have that flexibility to capture additional fields and so on. So that all those things become a big challenge. So what is really needed in today's world to extract the data from telecom backbone is basically deep packet inspection, which can cater to the high speed data and also generate the audit grade data, meaning the data with the highest of the accuracy and minimal losses. And all these three actually present a completely challenging balance. So if you try to capture the data at high speed, there are chances that you'll lose. So it's like juggling the three balls: high speed, real time, and audit grade. One of these will have to be compromised to actually get the data. And this is what presents the complete set of challenges in data collection. Just to give you a picture how the data would be collected, I mean, I'm talking about data getting collected and what will be collected. So basically, if we look at a 5G network, then there are various interfaces, and those yellow squares that you're seeing, these are the points where the data can be captured, which means we can look through the packets that are flowing in the network. We can get the metadata from the packets, and based on that, we can create event data records, or EDRs or XDRs, which can be then later analyzed in real time to give the insights into the system. So what exactly is the challenge with the data? The telco big data that we are collecting has a big volume, because billions of records will get generated in a day, which amount to terabytes of data. Just to give you a picture, a typical tier 1 telco with about 40 million subscribers can have 600 GB of data, CDRs, call detail records, generated in a day. This is what we have seen, and thus the volume is too high on per day basis. And this is just CDRs. If you're analyzing the packets, then it could be actually terabyte, 1 terabyte of data to 2 terabyte of data in a day that gets generated. Variety. There are the variety of data. You can actually collect the data coming as the counters, the performance monitoring counters that are generated by the individual nodes, or maybe unstructured logs, or semi-structured alarms. So basically, the data can be structured, unstructured, semi-structured as well. Value, we have to find out what is the useful data and how we can use this. This I'll come to it later. The velocity, because with the 5G, the throughput increases, the speeds are very high. It is the streams of data, that user data, that we have to capture, and that to record it in near real time. Plus veracity, which means many a times we may not be sure of the origin or availability or completeness. I talked about the challenges, so completeness of data is also a challenge. All these 5 factors actually make this telco data as the big data. So what is the value proposition of the data when it comes? So telco can use this data for their internal purposes or for external uses. And what they can do for internal uses, they can use the same data for improving the network or for improving the value to the customer. From the external users point of view, this data can be providing the additional services, or data can be given to government for social use. So now I come to the specific usage and applying analytics on the data. So we have talked about the network, we have talked about the data that is being extracted, and so what use can we put uh, to this data? How do we capture it, and what do we do about it? So subscriber intelligence is a very good term. I thought it would be really important to say in terms of what can we know about a subscriber of a telecom company, what can we know, and how we can utilize this data. So telecom companies have been using the data over their existence, and in fact, pretty much from 2011, there have been very structured usage of data. So traditionally, telco use the subscriber data to improve their network and operations, customer experience, and for promoting their own services and products. What we are looking at as is they need to evolve to use this subscriber intelligence data for third party to support businesses in customer acquisition, help with customer growth, and help customer retention. This is the way they can actually monetize their data further. And why it was not done till now, there are many reasons, but typically there were the footprint of the solution was very high, control plane data was being used, and the telco data was considered inferior. I mean, typically Google has more data about us as compared to any telco, even if we are accessing the information through our handsets. So how telco data can be made more, better and more suitable for businesses, so that people, the businesses do not only partner with Google, but they also get telcos also get chunk of that pie. So if I try and explain this traditional data network operations and efficiency, so basically you can improve network quality if you can figure out where are the holes in the network, that is blackouts, or the areas where connectivity drops. You can find out the network issues in terms of measuring the success rates, how the mobile is getting attached, how the calls are handed over, and so on. And the data was used for faster fault detection and resolution, for customer experience enhancement, for better customer satisfaction scores, for reduced churn. And it was also used for new services decisions, that is what kind of services will be used, what kind of products or handsets can be promoted, or what new plans will be required, so that our ROI increases. The problem, actually, even with that usage, what are the problems that are coming into play? While I'll start reading it from the right hand side, or rather presenting, customer thinks that my internet is slow, or my Facebook app or XYZ app is not working, my network is getting disconnected. Whereas network operations, NOCs, will see that my network performance is good, no outages, customer care calls are taken care of, and there are no alarms or threshold breaches. But still, there are 40% subscribers who will have problems, and they will fall in the network department. So there are gaps. So while customer thinks there is a problem, network operations could not see the problem unless they see the data, they capture the data from the telecom networks. Similarly, there is another dimension to this, which is network and business planning, where you invest for the network. That is, let's say you create a new tower, but actually the revenue does not increase, or you offer a new service or new packs, and they do not get picked up by the subscribers. So basically, they do not sell. So there are gaps, and those gaps can be filled only by analyzing the data, using the data that is available with telco. So how telcos are in unique position for data mining? Actually, telco becomes a pipe for all kinds of services, like OTT content providers, e-commerce, payment services, gaming providers, etc. And with this, telco becomes a common data pipe across various business domains. So what telco can do? Ideally, individual businesses segments, they have rich data. For example, Netflix or Amazon Prime will have more data, more idea about your preferences based on what you have watched, and thus they can recommend what is needed. Telcos cannot figure that out because they cannot see what is flowing in. Even when you are viewing YouTube, they do not get to know which video you are viewing and what is the genre of that video. What is it a song? Do you like movies, or do you like vernacular videos, and so on? So they have richer data, but telcos have a different dimension of data. That is, they have cross section of data from various domains. So telecom operator can know that out of my total subscribers, how many are accessing Amazon, how many are accessing Netflix, or how many are accessing YouTube, and so on. And similarly, if telecom operator can know how many are using Amazon or Flipkart or Alibaba or whatever. So what telecom operator gets is a intersection of all these, and therefore we have telecom operators have a distinct position, and this data they can use for monetizing the information. If we just try and look at the telco advantages in terms of available data, there are various sets, in fact, 8 different sets of data, but they already have a big subscriber base with 70 to 90% population coverage. They know about the types of handsets. They know about the subscriber interests in terms of content that is being consumed. They know the location information with the time series, and that's why the telecom operators can actually say that which path or which route you are taking. And with the content provider usage, they can figure out what is the time spent, what is the usage, what are the popular apps or websites, and gaming. So whether you go to gaming, you like gaming, or you like viewing the videos, or you like reading news, or maybe watching sports or whatever. So all this information is already available, and it is across the 70 to 90% population coverage. And this is a very unique position that telecom operators can use. How many subscribers, telco subscribers, or how many percentage of people within the population actually use online content? They may not be there, but at least with the mobile handset users and telecom operator subscribers, they are accessing this, so they can actually figure out what is the usage or what is the pickup of these services. Similarly, if we move on, what the subscriber intelligence can provide actually is customer acquisition to find out the target audience, to ensure better hits. You can broadcast a message and get, let's say, 5% hits, whereas you can find a target audience and send the promotion, and you can actually get a 30% hit, which is far better and less expensive as compared to broadcasting this stuff. And even many times broadcasting may not be possible. Similarly, customer growth and expansion can be done by offering value. So somebody having a package for Netflix, you can actually bundle your own plans, the telecom operator plans, along with the content packages. Like Airtel in India used to package Amazon Prime, or sometimes Netflix, 3 months or 1 month of Netflix, depending on what kind of user is there. So thus you can actually grow your customer, you can grow your customer base, and many a times you can retain your customer by meeting his needs continuously. So the business drivers for such a decision are digital ecosystem availability, maximize the customer lifecycle value, and to increase the revenue and hybrid revenue. So basically, when you club these, you are generating the hybrid revenue streams. And the companies like this are already using this information, the subscriber intelligence, to promote their content. Rakuten and Jio, Rakuten in Japan and Jio in India are using it much more effectively now. There are lots of questions that will come up across within which need to be addressed or answered from the data itself. For example, operator can ask which applications or content providers and OTT players are popular in my network, or maybe who should be my most preferable digital partner. Why should Airtel offer only Netflix packages? Why not Amazon Prime packages, or maybe some other digital partner for its services? Similarly, which applications are actually consuming my network resources, or how the cache server like Google Cache Server or CDN who are popular and which are critical services. Similarly, what are the killer or rogue devices? For example, there are a lot of phones from local market which will actually create a lot of burden on the network resources by continuously firing, for example, location update or heartbeats or these kind of messages where network resources get consumed. So which are the devices you can identify which are consuming a lot of signaling resources, and what is my subscriber or behavior or usage pattern, and what is the quality of service. So ultimately all these questions can come to a set of tactical solutions which can be applied, and a lot of business values that can be arrived at by analyzing this data and trying to answer these questions on the left hand side to get monetization of the data. The same questions, when they are asked in a very different perspective, for example, who are the subscribers using the highest volume of gaming apps from outside my telco or digital partners, or which high value subscriber with pending complaint experienced consistently bad quality of experience in last 2 days. The moment you make these questions specific with a different perspective, you are now looking at, from instead of business, now you're looking at subscriber. And to answer these questions, we can use the same data to do subscriber micro segmentation, as in user type, which is, for example, somebody who has a high mobility and is or there are users which are streaming heavy, or a gamer, or a fintech user, or browse or having browsing interests with travel, food, sports, etc., or even reading news, and usage levels: high user, medium user, low user, and at the end the quality of experience and customer satisfaction levels. So basically we can repurpose this subscriber intelligence for telco and use this data to answer a lot of questions in very different ways, and thus decide and come to a conclusion as in what is the best value that we can offer. Typically going ahead and trying to explain instead of being very abstract, here I'm trying to pick up a use case. For example, this is a real data. A lot of MSISDNs or phone numbers are hidden here, but if we look at it, these are at the bottom, these are the mobile numbers, and on the Y column we have number of subscriber visits. So for example, this particular subscriber visited travel related keyword to tourism.info for 632 times, and this particular subscriber went to booking.com for 105 times. What we can conclude from this simple data, that if we search for travel and if we can target these subscribers, we can actually offer them simple travel offers. That is, okay, this particular offer is available. That way you are able to direct or make a targeted campaign, and also there are very good chances that you will hit the offer would be picked up. Similarly, instead of travel, we can track news, we can track sports, we can track gaming, and thus we can offer various services or packages inclusive of third-party partners, and thus we can increase the revenue stream not only for the telecom operator but for the businesses as well. This is real data from one of the operators with handsets. Which are the popular handsets, and if you want to promote a certain handset, what will be the features that will be picked up, what are the important features of the handsets or services, or what is famous. So you can, the telecom operator can actually decide and partner with the handset providers or OEMs, and then they can promote their packages. In fact, many a times dual SIM can be identified, whether these handsets have dual SIMs and are both the SIMs subscribed to the same. I mean, in India, for example, there are lots of people who will be using Airtel and a Jio SIM. So can we figure out that there are subscribers who are having these two different SIMs or not? So dual SIM and how they are being used. So those things can be tracked, and this gives a very good value proposition in terms of what handsets, a handset maker or handset model which we want to promote with our packages. Another typical use case that comes from the data which is flowing through the telco pipe is financial, bank, insurance upsell or cross sell. For example, if we just look at the SMS that are going to the bank customers, and if we can just peep into it, we can figure out which of the subscribers have spare money in their account, and by their customer profile we know which of them are between the ages of 25 to 45 and living in cities based on their location data, and they commute to office, and this is very easily known because of the locations and time series information. Then we can actually say that these are my prospective buyers for insurance or new bank accounts or housing or vehicle loans. Similar to this, we can also have data about bus ticket offers through SMS or USSD. If we can figure out subscribers who travel locally or they travel interstate but do not buy tickets online, and travel in festival times, or they travel on weekends, and they haven't visited any car hiring or cab hiring services, then this intersection is people who can be offered discounts on bus tickets and promotions, or maybe train tickets and promotions. So this is how the data can be analyzed that is flowing through the telecom network, and we can generate third party some interesting insight which will be useful to third parties, and thus they can offer their packages. One more, for event planning purposes, let us say we have subscribers at a predefined location on a particular day at a particular time, and roughly they spend, let's say, 1 hour or 2 hours on that location. Then, and if those locations are like popular malls or hospitals or parks or and peak hours, we can actually give this information, and event planners can actually plan where certain event should be organized to get maximum audience and maximum exposure. And this kind of data can be given to government. In fact, this can be used to find out whether there is a collection of people happening or not. So telecom operators can actually use this data, analyze this data, use advanced analytics algorithms, machine learning, and pattern finding, and thus they can come to this kind of a conclusion as well. Another useful use case that comes with the analysis of data is capex optimization. Many times, we cannot figure out what is the real quality that is observed, quality of experience and quality of service observed by the end user. So we can actually collect a lot of customer facing KPIs. For example, this KPI is like click to first bit. So if you click on your phone on a link, how much time does it take for your first bit to arrive? Then application response time, for example, could be you press the link for a video and how much time it takes for that video to play. It will be in milliseconds, but that gives an idea. Or throughput. So you want to watch a video in HD, but actually you are getting it at SD or a lower, or it is buffering, so lower throughputs. All such kinds of statistics or characteristics, if we can find out, and by the way, these can be found out. These are patented algorithms, and we can combine the these factors, discover their relationship through various analysis. Basically, it is multivariate correlation analysis, and then we can find out the problems or prioritize the problems and even localize the problems in the network. Similarly, there is this one interesting use case that can be found out is that which cell sites are offering higher ROI, return on investment, using cluster analysis. If we can actually find out a lot of the information about how many cells, how many average users, and what is the throughput per user, and we can cluster those cells, we can actually find out that cluster 1 is the high cell profitability with high scope for investment, whereas cluster 4 is low volume, low user density cell, or this is an underutilized cell. So you can make an investment more near in the cluster 1 areas than near cluster 4. Similarly, which cells can give me the profitability in terms of usage, and thus the insight can be converted to action, to an outcome. Last but not least, this analysis of the data can actually find out these patterns. By the way, these are the graphs that you can see on the network operation center, that how the services are performing. And on this particular time, actually, there were a lot of failures which led to revenue loss to the operator. And if such patterns can be found out, they can be easily converted into the revenue opportunities and save the revenue. Till now, I was talking for everything within the operator and telecom operator, but how it will impact the fintech. So with the better throughput, higher speeds, more data, the mobile money and e-wallet adoption will increase. This will also enable wearable and VR, virtual reality and augmented reality banking. There will be enhanced security and fraud prevention and automated bank branches. How does this happen? So mobile payments will be more adopted because they are going to be at higher speed. So increased transaction speeds. The accuracy of fraud prevention, because you can now transmit more data. Instead of just the OTP, you can now transmit your face, you can transmit your thumb impression and so on. And it will be much more user-friendly experience. Similarly, data visualization with augmented reality and virtual reality, this can help in one thing, that you can present your data. Let's say you're spending for every month, how much you are spending in foods, how much you are spending in rent, how much you are spending in, let's say, clothes, and so on. If you can see that pie chart, it gives you a clear idea how you are spending, what you are doing. So all such things can be easily, done, manipulated, handled with the data visualization. And augmented reality can actually give picture or a voice to the data itself, instead of looking at it in a table, or maybe looking at your bank statement every month. Similar things actually have been done by BNP Paribas and Citi, where Citi has partnered with Microsoft HoloLens. Enhanced security, because of the higher speed, we can have multimodal biometric security procedures. As I said, thumbprint, fingerprint can be used, facial recognition can be used, and because of the low latency, higher speeds, the transactions will be more in real time, and thus there will be lesser chances of the glitches. So how data analytics for fintech fits into this whole space? There are connected devices, for example, your watch, your phone, smart devices, or even a wearable, glasses. Telco can actually track the real-time transactions. Then, as a digital enabler, it can provide secure connectivity, safe authentication because of the edge. And this data can be extracted, analyzed, and actionable insights can be provided. So this is how fintech will be using 5G. Similarly, if we look at IoT platform for wearable health devices, everybody is wearing a watch. Most of the people nowadays are wearing watches which record your heart rate, which record your steps, sometimes SpO2 as well after COVID. And these devices can actually get the data. Plus, if this can be added to the insurance partner data, as well as doctors' data, because doctors also carry tabs these days, and they are using a lot of applications to record their transactions. If all these can be culminated into one platform, analytics platform, then all this data can actually give benefits to insurance and general life insurance and general insurance, like health and travel insurance, because at the end, the insurance companies are more aware of the customers' habits, the patterns, the lifelines, and so on. And this can again be achieved through the telco analytics platform. So at the end with this, what happens is subscribers get discount for sharing medical history. They get consolidated health record at one place, which is easily accessible and shareable and useful in medical emergencies. Whereas digital partners like insurance companies or even government, they can get customers' medical history, which can be used for actuarial analysis and so on. And they can find out risks associated, and they can actually offer discount if the subscriber is not a risky one. I mean, he is living a healthy lifestyle, you can offer discounts. So newer insurance products can be designed. How this is different, we are not talking about typical policy bazaar kind of things where there are lots of policies, insurance policies which can be compared, but we are really talking about monitoring the health and utilizing that to offer newer insurance services. So this is how the data that can be actually captured at telco level can be analyzed, advanced analytics applied, and further predictions, predictive model, so health predictions or any other sorts of predictions as needed can be applied through the telecom data or the big data. The kind of platform, tools, and databases for such kind of analytics can be through open source platform where Apache Spark with Kubernetes, Apache Hive, Apache Tez, Apache Drill, and with custom ETL for data ingestion with HDFS file system can be done. And this can be deployed over proven deployment models like on-premise bare metal server or on-premise VMs, AWS cloud environment, Google cloud environment, and so on. Bottom line, here, this is where I would like to conclude. And I would like to say that there is a lot of data that will be available within 5G networks. Yes, the data was available in 4G as well, in 3G as well, but the volume of data and the services, the distinct services or distinctive services that will be differentiated services that will be available, and we can use the data flowing through the telco backbone, which can be used not only for telcos but for their digital partners and enabling them. So advanced analytics and big data analytics actually can help with a lot of use cases, which I tried to show. This is not just the end of it. There are lots and lots of use cases which you can find. I have tried to cover the things that are possible, that have been and that can be useful, not just talking about the cars or the operations which are like 5 years down the line. Thank you. And I say namaste. I just request you to be safe, wear masks, and follow social distancing. Thank you.
Hey Anurag, thanks for your very detailed presentation on the data and also some case studies from a telco perspective. And yes, stay safe, like what Anurag says. Yeah, okay, now we are opening to the floor for some questions. So if you're shy, just feel free to type inside the chat box, okay? And then alternatively, you can actually switch on your mic and camera to ask your questions. All right, so we actually have a question already from the chat from Ayataka. So how will 5G latency be lower if processing is already being done in the cloud?
Oh, this is, thank you for that question. Basically, 5G is talking about bringing the services through MECs near the edge, cloud edge. So virtually, if one had to imagine, we would say that literally it will be sitting near the towers. So the baseband servers would have those MEC systems or mobile edge computing systems sitting along with the towers, so that this using service-based access, you can actually get the data pretty close to yourself. And that is why I mean, the processing will not remain in the cloud, but if it remains in the cloud, you are absolutely right that the latency will be there. But 5G it itself is bringing this the services closer to the user by deploying MECs, mobile edge computing.
All right.
Okay, I read that. So Yeah, 5G, so operators are actually trying to talk about 5G, and they are offering those services. I think Japan and South Korea are really leading there. And as far as I remember, Singtel offered some 5G services last year, I believe, or maybe 2 years back. But this is not really common. And frankly, if I had to decide, I would still say 4G is sufficient enough for us for the moment. Uh, so it will take. So basically, this is the stage. I would call it as a transition stage where we are migrating from 4G to 5G. It is not only technology which is restricting us, but uh, along with that, it is the capital that is required to do that. Just to give you a rough, very rough figure, the capital expense for deploying 4G, if it was X, for 5G, it would be 10X, because the number of sites would increase to provide that coverage. And in my personal opinion, this is my personal opinion, that 4G and 5G will continue to coexist.
All right, we have another question from Group Rash. It's true that 5G will catalyze the next wave of Internet of Things and also help to improve efficiency as a whole in the future. But why do some organizations still express anxiety despite all the bright side that's being painted out there?
Yep. So see, we all, when we look at IoT, really, what are the solutions that we are seeing? In fact, I was last year, or yeah, maybe 14-15 months back, I was talking to somebody in Singapore. That was a company which was providing IoT devices for logistics, and they could actually figure out figure out whether the temperature was maintained for their food deliveries or whatever items that they were delivering to Europe through sea route, whether the temperature was maintained or not. And the other, mostly the IoT devices are being used by the logistics companies for locating their containers or trucks or whatever. Uh, Real automation will take a little bit of time, and there have to be purposed devices to get to that IoT, plus the analytics that are possible. There are fears in terms of, okay, I'll take one thing. Let's say you are having a pressure sensor and a temperature sensor in a boiler kind of an environment, and you don't know which one is, whether it is right or wrong. Do you really want to let the machine take a decision on its own, or you want to actually validate that decision and then take it? So while the brighter picture always talks about, oh, machines will take decisions on their own and they will continue, but actually still there is a fear we cannot give the control to the machine totally, and that's why there is a hitch, and that will continue to be there till the time you actually see it. Frankly, I sat in a Tesla, then and then only I realized what Tesla is and what are the things. But if I can talk about it, but not understand what Tesla can do, and may not feel safe and secure. Okay, when do you think businesses should start considering about the adoption of 5G and advanced analytics? If I just started my company, do you still think it's suitable for early stage company like mine? There is no yes or no answer or a direct answer to your question. Depends on what space you are in, what kind of domain you are working in, what is the real, whether there is a real requirement of connectivity and real-time data and higher bandwidth. Based on that, we can actually advise whether it is needed or not. For all practical purposes, if we are downloading the movies, 4G is good enough. If we are watching movies and sports and everything, 4G is good enough. It may not be necessary right now to go ahead with it. Sorry, I mean, I have been talking about 5G in my presentation throughout, and now I'm talking different, but this is the practical aspect of it. But early adopters will certainly see the advantage. They will have to go through teething troubles as well. I hope I answered your question. Thank you.
All right. Do we still have any more questions? Feel free to,
Hi, Anurag.
Sure.
Hi, Ayush.
So a very nice and exhaustive presentation. So I have a couple of questions.
Yeah.
Hello.
Thank you, Ayush. Yes, thank you. I can hear you. Please carry on.
So first thing, where do you see you talked about the type of data a telco has. You mentioned CDRs. So where do you see the future of CDRs when most of the traffic is now shifting to application-based communication like WhatsApp and all? So first thing, isn't the telco experiencing a loss of revenue from that end?
No, telcos will have to evolve the mechanisms. Actually, if you see, the telcos have been evolving over a period of time. Remember when 2G, 3G were there and new BlackBerry devices were launched, basically you would have packages with 100 MB data or maybe 1 GB data over a month. But slowly we have evolved in India, at least, to a level where you are talking about 1 GB data per month, and actually you are not charging for call. So the packages will certainly evolve over a period of time. WhatsApp kind of thing, which are taking away, I mean, the OTT applications, which are taking away a lot of revenue from telecom operators, and that's the reason for ARPU to fall. But really, the connectivity provided for IoT devices and the enterprise type of connectivity will be the key thing that will play a role. In my opinion, individual subscribers are there, but they will be associated through some or the other, in one or the other way, through a different kind of package. Simply, okay, let me try and think a bit loud in this, as in, maybe you will have a subscription for your IoT devices at your home with the control as well, and that whole package of smart home plus your mobile could be offered for X amount of rupees, and that's how your whole billing mechanism and systems will change. Billing is not going to, CDRs are not going to go away, because that's how you're going to charge. That's how you're going to measure. But the presentation itself will change. So I hope that answers your question.
Packages will, yeah, I get your point. Packages will evolve more of a database subscription models.
Yeah, maybe, yeah. So what, there could be many more thought processes. I've just given you one bit from my side. Yes.
My next question is like regarding the telecom analytics platform that you were talking about. So a telco is limited to only interpret data till network layer 3 of a network model. Till network layer, till IP-based layers, they can interpret data. Because of the HTTPS secure communications and all, I don't think that they can interpret data above level 3. So only till IP-based, they can tell them like, okay, from which IP, what IPs are requesting, how much, like for example, you talked about Amazon, like how many hits are there on that.
So I just to answer this, sorry for jumping into it. The answer to this is there are lots of DPI libraries and DPI systems available, which are able to analyze this data even with secure layer. That's one, and many a times using heuristics. For example, and heuristics is a good mechanism to understand the stuff. I cannot talk about a specific DPI library which I am aware of, but they are still able to decode a lot of information up to application level. That's one. Second thing is, when you are accessing HTTPS, headers will certainly be there and they will be read. So for example, you are accessing YouTube, this will be interpreted, but certainly not the video that you are watching.
Okay, till headers we can interpret the data. Like,
yeah, there is a possibility. If you if you are going to Times of India, for example, I know you want to read newspaper, Times of India, Indian Express, or maybe Straight Times in Singapore, or something like that. So based on that, you can actually figure out what are the interests. If you are hitting, if you're trying to go to a bank, DBS, Deutsche, HSBC, at least that will be known. It's not all hidden.
Okay, sure. That answers my presentation. Thank you, Anurag.
Yeah. Sorry, there was a question about, can you break down how will 5G latency be lower if processing is being done in the cloud? Okay. What do we understand from cloud? When I was, let me just pull up that picture and I'll try to show how it is different. Just a moment. Where's screen? Here, if you see on the right top, cloud, this is also a cloud, this is also a cloud, and with 5G, actually, this will also be a cloud. Depends on what kind of cloud it is. As in, this could be public, this could be private. Normally, core network will be a private on-premise cloud. And similarly, this would also be cloud. That's one part. Second, there will be network slices that will be created for specific services and specific requirements. So here, where the media service was sitting on the cloud on internet. So basically, it was internet even for the telecom operator. So if it was coming, there is latency introduced because of this. But if the service comes on the telco cloud itself, and it resides here, this will reduce the latency. That's what I was talking about. I hope that answers the question. So this is how the difference is. So basically, your router to edge computing, mobile edge computing, cloud, and this is where your services or applications will be hosted, and they'll reduce the latency. I hope that explains it.
All right. Do we have any more questions from the ground? If no, if you have any more questions, feel free to connect with Anurag. Okay, we already sent the link in the chat. If not, Dylan will resend the links so you can connect with Anurag and actually ask him more questions. All right. So because due to the time constraint, we will push everything to LinkedIn. All right. Okay, or you can choose to actually scan this QR code over here to connect with Anurag. If you wish to, find out more about such events, you can actually connect with me on LinkedIn to find out more. All right, so as a show of appreciation for everyone over here, Xperinia is actually giving free 1 month premium access to all these insights and items over here as stated below over here. Just by scanning this QR code, all you need to do is just register an account and then activate, and you will have access to all these items over here. These including Anurag's insights and short videos, as well as this event, okay, which we will repost the replay. If you have missed out anything or your friends couldn't make it for this event, you can actually ask them to register an account and access to this replay. All right. And also for future events, if you do not have time to attend our Thursday 8 p.m. events, you can also check out the replays over here. And also for our past events on different topics from our different industry experts, you can actually also get full access to all this. All right. So without further ado, if that's all from me and Anurag, is there anything that you would like to share with the audience before you go?
Yeah, just wanted to say thanks, and thank you for asking questions. It was and thanks to Xperinia for giving me this opportunity.
Yeah, you're welcome. Thank you for coming over here to share with the audience on such detailed explanation, and the questions are actually interesting. All right, so yeah, stay tuned for more updates and more events in the future, and I'll see you guys next week. All right, good night.